Let's talk about chemical bonds. Chemical bonds are compounds, composed, I'm sorry, I can't even read. Chemical bonds are compounds that are composed of atoms that are held together by chemical bonds. All right, we've already defined compounds. We said that compounds consist of two or more, hang on, let me find my microphone, two or more elements that, different elements that are chemically combined. And what we're going to start to learn about here is how that works. Chemical bonds result from the attraction between charged particles, electrons and protons, that compose atoms. And chemical bonds are broadly classified into two types, ionic and covalent. Ionic bonds, which occur between metals and nonmetals, involve the transfer of electrons from the metal atom to the nonmetal atom. The metal atom then becomes a cation, while the nonmetal becomes the anion. One way to remember this, cation has a plus sign in the middle. The T could be considered a plus sign. So cations are positively charged. Positively charged means that you have more protons than electrons. Negatively charged means that you have more electrons. Okay? These oppositely charged ions attract one another by electrostatic force and form an ionic bond. An electrostatic force is static cling. You have all experienced a moment where you have trudged your feet across the carpet in your socks and worked up a charge and then snuck up on somebody and touched them and shocked them. Or you've been turning the TV on or something and gotten a shock. I can remember when I taught junior high, the kids had figured out if they sat in their seats and moved around in their seats, they could build up enough static charge to shock the person sitting next to them. All right, you've all experienced static cling. What that is you build up excess electrons on your body, and then it'll attract, if you've got, for instance, Danny Hopkins, first grade, went to school. His mother's pantyhose were stuck to his jeans. They had come out of the dryer together, and the pantyhose were stuck to the jeans. Now, the teacher just pulled them out. Everybody laughed. Danny Hopkins wasn't scarred by it because he told the story when he was in 8th grade in my class, and everybody laughed. But that's an example of static electricity. There's a Friends episode where Monica meets up with Richard in the video store, and he's plucking underwear off of her sweatshirt. Because, again, the underwear was attracted to the excess electrons on the sweatshirt. All right? So that's the electrostatic force, and that's what's happening in a ionic bond. You have particles that are positively charged and negatively charged next to each other, and they are attracted. The basic unit of an ionic compound is called a formula unit. Okay, ionic compounds do not actually make molecules. They make crystal lattices. Hang on, I'm going to get an example. Well, somewhere in here there is a salt molecule, or somebody has borrowed it because I don't have it anymore, but this is what a salt molecule looks like. I have a model as well, but this is what one looks like. So, a salt molecule is not a molecule. It is a crystal lattice. You've got these repeating, and I don't think I can draw on this, so you've got, if you can see the cursor or not, you've got a repeating here, sodium, chlorine, sodium, chlorine, sodium, chlorine, sodium, chlorine. It sets up for what we call a crystal lattice. All right, and the basic unit of that is whatever the smallest ratio is, which is called the formula unit. All right. Table salt is an ionic compound with the formula NaCl, which is composed of sodium and chloride ions in a 1-to-1 ratio. All right, here's an example. Sodium metal, chlorine gas, the sodium metal mixes with the chlorine gas, and basically it gives off one of its electrons. Remember, sodium's in the first family. He needs to lose one electron in order to be happy. Chlorine is in the 7th family. He needs to gain one electron to be happy. And so they share electrons. That creates that attraction, that positive-negative charge, and they bond together. Covalent bonds occur between 2 or more nonmetals. The 2 atoms share electrons between them, composing a molecule. So sharing is what we call our covalent bonds. So there's 2 kinds. The first kind we said was a transfer. One electron goes from one element to another and creates a charge. Sharing, they share the electrons between themselves, and they become what we call a molecule. Covalently bonded compounds are also called molecular compounds because they make molecules. So ionic compounds are not molecular. They do not make molecules. Covalent compounds do. So here is an example with oxygen. If this is water, oxygen has 6 outer shell electrons. Hydrogen has 1 electron. Hydrogen wants to get rid of his electron, so he gives his electron to oxygen, but he doesn't really give it completely because he still wants to kind of hold on to it. So what he does is he puts that electron out here. I'm going to redraw these. 1, 2, 3, 4, 5, 6. And I'm going to change colors. Here's the hydrogen atoms. So now hydrogen wants to have 2 total, or have 0, and now he has access to 2. Oxygen sharing. But oxygen also gets to hold on to these. This is kind of like shared custody in a divorce battle. The electrons are being shared. So there's 2 electrons being shared. 1 comes from the oxygen, 1 comes from the hydrogen. 2 electrons being shared, 1 from the oxygen, 1 from the hydrogen. Okay? When we talk about chemical formulas, the chemical formula tells us what is in the compound. It tells us what's there. Water is represented by H2O. It's not H2O2. And no, this isn't in your notes. I'm just going over it. Sodium chloride is represented as sodium chloride, NaCl. Carbon dioxide, CO2. Carbon tetrachloride, CCl4. Go on. And let's talk about molecular elements. Molecular elements are elements that make molecules. One of the things you had to know was the difference between a molecule and a compound. A compound is 2 or more substances chemically combined. A molecule could be 2 same atoms or multiple atoms that are different chemically combined. These guys in yellow are what we call elemental molecules. All right? They form in pairs, and we actually refer to them as the Hofbrinkels. All right? They're the Hofbrinkels. It's just a creative way of remembering that. Then you can see these peach ones, phosphorus, sulfur, and selenium, they can all exist as multiple. Phosphorus can be, I know sulfur can exist as 8, S8. I'm not sure what groupings phosphorus exists as, or selenium, but all of those can have more than 2. So these are called diatomic, and the others would be polyatomic elements. All right. Oh, P4. That's the other one. All right. Molecular compounds are composed of 2 or more covalently bonded nonmetals. So let's go back to ionic real fast. Ionic taken all those slides out. Ionic, you have a metal and a non-metal. Okay, that's key. Covalent, you have two non-metals. So when you think about the periodic table, if you have one from this side and one from this side, it's ionic. And if you have two from this side, it's going to be covalent. All right. The basic units of molecular compounds are called molecules, and they are composed of the constituent atoms. In other words, they're made of the atoms that make up the compound. Water's H2O, dry ice is CO2, propane is C3H8. So, here we've got that crystal lattice again. Over here you can see we have individual molecules. So the crystal lattice for salt, even though there's lots of sodiums and chlorines in there, when you break it all down it's a 1-to-1 ratio, so you write it like this. But here we would have to go through and count the number of white atoms, which happen to be hydrogen atoms, and the number of black balls, which are the carbons. And this looks to me like it's probably ethane, which is C2H6, because I'm counting 6, 1, 2, 3, 1, 2, 3, 4, 5, 6. Maybe not. I don't think that's a really good representation, honestly. Maybe it's supposed to be propane, C3H8. All right. So if we summarize our compounds, ionic compounds contain positive and negative ions. In a chemical formula, the sum of the charges of the cations must be equal to the charges of the anions. So if you have Mg plus 2 bonding with chlorine, who has a -1, you're going to need 2 chlorines in order to use up both magnesium's ions. The formula of an ionic compound reflects the smallest whole number ratio of ions. The charges in their representative elements can be predicted from their group numbers. That's the happy atom chart. Representative elements form only one charge. Again, happy atom chart. Transitional metals can have multiple charges. We'll learn how to name those. And so those charges cannot always be predicted. All right, we will stop for there.